A five-story car park was constructed using long post-tension beam as part of an unpressed concrete frame supported by square columns. The beams with dimension of 575 mm depth and 2000 mm width were cast in Singapore and had a six span of 15.6 m each. Hollow core units were placed between the beams, which were positioned at 7.2 m intervals. After 3 days, the beams were stretched to the required force. However, about 5 to 6 days later, extensive cracking occurred throughout the structure, affecting both the columns and beams, with some cracks exceeding 0.7 mm in width. The cause of the cracking needs to be investigated. To investigate the car park building failure, the following tests are recommended. The first one is material composition analysis, where we examine concrete samples for quality and compatibility. The second one is compressive strength test, determine the concrete strength through controlled compression test. For the third one is post-tensioning force verification, where we confirm the actual forces applied to the beams using load testing or non-destructive techniques. The fourth one is structural integrity assessment, where we use non-destructive testing to detect defects and weaknesses in the concrete structural elements. The fifth one is load testing, where we apply control loads to evaluate load-bearing capacity and identify structural deficiencies. These tests will provide crucial information to understand the failure and take appropriate corrective actions.
I'm Lai and I will be present to answer the question 2 for case 1. In this case, we make the assumption that the frame is taken at the side of the first beam of the car park building with the placement of the slab and floor screed due to tight schedule mentioned in the question. By referring to the knowledge of reinforced concrete design, the final UDL that we analyzed and obtained on the beam is above 65.057 kN per meter. After that, we analyze the moment by using moment distribution method. The first step is to calculate the member and the joint stiffness, followed by the distribution factor for all members at the joint. After that, we proceed to determine the carryover factor and fixed end moment, which WL squared divided by 12 is used for constant UDL. Lastly, we complete the distribution table by using Excel spreadsheet. Attached is the bending moment, shear force, and axial force diagram obtained from the case 1.
I'm Yang, and I'll be discussing about case 2, where the gravity load is similar to case 1 together with post-tension force applied on a frame's beam. So post-tensioning is a technique used to strengthen and reinforce concrete and the structures by applying tension to steel tendons or cables after the concrete has been casted and cured. And this process helps to counteract the effects of bending forces and increase the load carrying capacity of the structure, which helps to reduce the overall tensile stress in the concrete, particularly at the bottom of the beam where the tensile is highest, leading to a decrease in bending moment. And we are considering end-span tendon profile for the beam with parabolic shape, where the eccentricity or depth of the tendon varies along the length of the beam. As we can see clearly in the diagram, a counter UDL of 16.968 kN per meter is acting on the beam BC. Here's our SFD and BMD diagram after post-tension force applied.
Hi, I'm Xavier and I will be answering the question 3.1. The reason for the observed cracks and damage caused by the post-tension force depends on the stress level created and the capability of the concrete and reinforcement. The post-tension brings extra force into the structure, which can cause cracks and damage if the force exceeds the capability of the concrete or reinforcement. The stress level should be verified within the structural components limitations. Once the stress exceeds the limitation, or there is a construction flaw, it will cause and observe cracks and damages.
The timing of post-tensioning is crucial because it interacts with numerous elements such as concrete curing, shrinkage, and post-tension tendon realization. Improper timing or failure to address these aspects might result in cracks and damage. For example, if the concrete is not properly cured or if the tendons relax excessively over time, it might cause unwanted motions and stress redistribution, resulting in cracks and structural damage. Adjustments in building processes, curing methods, reinforcement details, or post-tensioning procedures may be used to avoid these cracks and damages in the future by applying the modifications on them, improving quality control during construction, guaranteeing correct curing and moisture management, improving reinforcement placement and detailing, and optimizing post-tensioning operations to minimize stress concentration and prevent excessive movements are all examples of what this may entail. Various actions can be taken to reinforce the car park building and alleviate the detected cracks and damages. This might include adding reinforcement in important locations, retrofitting techniques to increase structural capacity, enhancing connections between parts for improved load transmissions, or rethinking the design approach to address possible weaknesses. Specific recommendation will be based on a thorough examination of the structure and examination of the failure mechanism and consideration of the project's limits and requirements. That's all for us. Thank you.